Hey, welcome. Let me introduce you to my good friend Trapezoids. This guy, we grew up together. Really cool dude. I wasn't really good at basketball growing up, so we once played one-on-one, and he let me win. Wait, no, hold on. I'm thinking about Teddy. That's Teddy. That was my friend growing up. We're talking about trapezoids. Yes, trapezoids. That's what I meant to talk about. What is a trapezoid? Well, I'll tell you what a trapezoid is. It is not a parallelogram. All right, it is a quadrilateral, and a trapezoid is a quadrilateral with only one pair of parallel sides. All right, so remember, our parallelogram had two pairs of parallel sides. This only has one pair. Now look at this trapezoid right here, A, B, C, D. Which two sides look parallel? You thinking about it? Good. AB and DC look parallel, okay? And so those are called our bases. The parallel sides of a trapezoid are called our bases, and they're parallel. So the bases of a parallel, bases are parallel, so AB is parallel to DC. All right, bases in a trapezoid are always the parallel sides. All right, now look at this again. Which two sides are not parallel? Well, that would be AD and BC. And right, if they kept going up and up and up, they'd probably intersect, okay? And those are called, our non-parallel sides are called the legs, all right? So these are our non-parallel side, non-parallel sides. And please write this along and label everything. And remember, these are our bases. The parallel sides are the bases. All right? So those are some terms you need to know about trapezoids. Now there's only one fact about trapezoids that you need to know. And that's angles on the same leg are supplementary. And angles on the same leg, well, if you look at this, A and D, they're on the same leg, right? They're both on this leg right here. Those would be supplementary. But why are they supplementary? I think that's a good topic to explore. And let's just talk about that for 2 seconds, okay? I think knowing why is an important thing. We know that AB, all right, is parallel to DC. You might remember me doing something like this with trapezoids. And we have this transversal right here, which is our leg. AD, which is our leg, is the transversal of these two parallel lines. Now to bring it back, I'm bringing it back, these two angles that are on the leg, what will we call those two if these are parallel lines? Same side interior angles. And what do we know about same side interior angles? That they're supplementary. Oh, that's why he said all that stuff before. See how geometry coming full circle, pretty cool here. So since AD is the transversal here, it's the leg, we know that angle A is supplementary to angle D. A and D are supplementary angles. Similarly, if you look right here, BC also makes a transversal. So these two are also same side interior, so angle B and angle C are are supplementary. And that's your little facts about trapezoids. Now what we're going to be focusing on really is isosceles trapezoids. Those are like the famous kid of trapezoids. This is the one people really like to talk about. So an isosceles trapezoid is a trapezoid with congruent legs. Now they're not always congruent, right? Only in trapezoids, isosceles trapezoids, are they congruent. So our first fact about isosceles trapezoids is what? They have congruent legs, all right? That's one of the properties of isosceles trapezoids. And in this case, remember, the non-parallel sides are the legs. So in this case, AD would be parallel to, not parallel, is congruent to BC, right? Because the legs are congruent. Congruent. If this was 10, this would also be 10. The legs are congruent in an isosceles trapezoid. The second property is, since it is a trapezoid, the angles on the same leg are supplementary, all right? Because it's a trapezoid, it has the same trapezoid facts. So in this case, these two angles, A and D, are supplementary because they're on the same leg. So angle A plus angle D equal 180. The same thing is true for the other side. B and C are also supplementary. And remember, since it's true for all trapezoids, it's definitely true for an isosceles trapezoid. Two more properties. We know base angles are congruent. Base angles are congruent. Now, what is a base angle? A base angle are angles that are on the same base. So if you look at this, DC is a base and AB is a base. All right? Remember, those are the parallel sides. Now, the base angles are the angles that are on the same base. So in this case, A and B are on the same base. So I know angle A is congruent to angle B because they are on the same base. And angle D is congruent to angle C. Why? Because they also share a base. So angles that share a base are congruent. And finally, we know diagonals are congruent. All right? So in all isosceles triangles, and just isosceles trapezoids, are they congruent? So in this case, diagonals are congruent. So BD is congruent to AC. So those are your 4 facts about isosceles trapezoids. The legs are congruent. The angles on the same leg are supplementary. Base angles are congruent. And the diagonals are congruent. All right, in the diagram below of trapezoid WXYZ, WX is parallel to YZ. Name the bases and legs of this trapezoid. Okay, so remember, the bases are the sides that are parallel to each other. So WX and YZ are parallel to each other. So those would be our bases. So WX and YZ are our bases. Okay? And the legs are the non-parallel sides. So the non-parallel sides would be WZ and XY. These are our non-parallel sides. So those are our legs. All right. Awesome. Let's move along. In the diagram below of the isosceles trapezoid ABCD, AB is parallel to DC. AB and DC. And this is an isosceles trapezoid. The measure of angle A is 34 degrees and AD is equal to 12 inches. Find the value of the missing angles and sides. Well, let's see. AD is equal to 12, right? And since it's an isosceles trapezoid, we know BC, which is the other leg, also must be 12 inches. Now this is the interesting part. We know angle A is 34 degrees, and we want to find all the rest of the angles. How do we do that? Well, the way we do that is this. 1, we know the base angles are congruent, right? So if this is 34, this is also 34 degrees. So the first thing we know is base angles are congruent. Now the second thing we know is that angles on the same leg are supplementary. So if we look at this leg, right? AD is a leg. These angles must be supplementary. So to find out what D is, all I have to do is 180 minus 34, and that gives me 146 degrees. So since these are supplementary, this is 146 degrees. All right, and I knew that because angles on the same leg are 180 degrees. Now once again, D and C are base angles, so they must be congruent in isosceles trapezoid. So this is also 146, and we did it. Okay, for our third problem, in the diagram below of isosceles trapezoid DEFG, DE is parallel to GF, and DF, which is right over here, is equal to 42. All right. Now we want to know what is the value of EG. What is this length? Well, if this is an isosceles trapezoid, what is the property that could help us solve this? Think about it for 2 seconds. Have you got your answer? Good. Right, we're talking about the diagonals. So what would help us? We know diagonals are congruent in isosceles trapezoids. So all we'd have to do is say that, well, DF is congruent to GE, right? Because they are diagonals. And if DF is 42, we knew EG must be equal to 42. Beautiful. Okay. Now, listen up because this one is a doozy. All right? Check it out. In trapezoid ABCD, AD is congruent to BC. All right? So let's mark that. If AB is equal to 20, and DC is equal to 36, and AD is equal to 17, what is the length of the altitude of this trapezoid? Now, what is an altitude? An altitude is this. If I drop down a line from a vertex to the base to make, from the base to make a 90-degree angle, all right, from the vertex to the base to make a 90-degree angle, then that is an altitude, okay? So a line connecting vertex to a base to make 90 degrees, okay? So it's perpendicular. That's what an altitude is. So we're trying to find the length of this line right here. It goes from the vertex to the base. Okay, well, let's see. I know these legs are congruent because this is an isosceles triangle. So let's put a 17 over here. And now I want to find out what this is. And, well, if you're looking what I'm looking at, here's what I'm noticing. Maybe I can make myself a right triangle over here, right? This, and this. All right? I have a triangle right here. A right triangle. And if you remember from our past lessons, we know how to find the missing side of right triangles. If only we knew two sides. So if I could find out somehow what this missing part is down here, I can find out what the other missing side is, right? Because if I have two sides, I can find the third missing side. And how am I going to do that? Well, I'll tell you. The way you do it is first find the difference between these two bases. So we're just going to do 36 minus 20, all right? And what that tells us is that is equal to 16. And so what I've done really is I've said this. These two lines, right, from here to here is 20, right? And that means this part, these two missing parts, right here and right here, are going to be equal to 16, right? Because if this is 20, I have 16 remaining. Now, in isosceles trapezoid, this and this are going to be congruent. So I'm going to take that 16 and divide it into 2, and that gives me 8. So I know this is 8 and this is 8. And now I have my two sides of my right triangle. Well, 17 is the hypotenuse because it's opposite the 90-degree angle, and now I just plug in. So I'm missing one leg, so it's a squared plus b squared, which is 8, equals c squared, which is 17 squared. A squared plus 64 is equal to 289. All right, a squared equals, well, let's take away 64 from both sides. So we get a squared is equal to 225. I take the square root of both sides, and I get a is equal to 15. So that means that my altitude right here is 15. So once again, if you get yourself that right triangle, then you can get yourself that missing altitude. So just follow these steps and you'll be good to go when they're asking for the length of an altitude. All right, final theorem, the trapezoid midsegment formula. Here it is. EF is a midsegment, all right? A midsegment is just like we did with in triangles. It's the point that joins the two midpoints of the side. So E is the midpoint of AC and F is the midpoint of BD. Another word for a midsegment is a median, just so you know. Now to find the length of a midsegment, this is the formula that will help you out. The midsegment, that's an S, is equal to the base 1, the top base, all right, so this is base 1, plus the second base, we'll call this base 2, all right, divided by 2. So if I add these two bases and I divide it by 2, that will tell me what the length of my midsegment is, or my median. Let's try it in practice. In the diagram below of trapezoid ABCD, E is the midpoint of AD and F is the midpoint of BC. So that is our midsegment. All right, so that means EF is our midsegment. Find the length of EF. Well, the way to do that is this. My midsegment is equal to base 1, which is 6, plus my second base, which is 8, divided by 2. So my midsegment is equal to 6 plus 8. Which is equal to 6 plus 8 is 14 divided by 2. And my midsegment is going to be equal to 7. So I just added my two bases, divided by 2, and my midsegment is 7. All right, let's try another one. JK is the median of trapezoid XWYZ. Find the length of XW. Now, XW is one of the bases. So how am I going to do this? And let me tell you how. What you're going to do is plug into your formula. The first thing you know is the midsegment, and the midsegment goes over here. So this is our midsegment, right? Here's our mid, and we plug in over here. 10 is our midsegment. Base 1 we don't know, so we're just going to call it X. We don't know it, so it's now X plus 14, and that's our other base. To solve this, the first thing we have to do is get rid of this 2 on the bottom. The way to do that is to multiply both sides by 2. All right? When you do that, these 2's cancel, and you multiply this side by 2, so you get 20. And 20 equals X plus 14. So we just multiplied this side by 2, and these 2's cancel. Now we just solve by subtracting 14 from both sides, and we get X equals 6. So our base over here is equal to 6. And let's just check to see if that makes sense. I always like to see if everything made sense. Well, let's erase all this jazz right here. Hopefully you copied that all down. If not, go back and do it. We found out that XW is 6. Well, let's see if this works. 6 plus 14 divided by 2 is equal to 20 divided by 2, which is equal to 10. And so that does make sense. If we add the two sides, the midsegment is 10. All right, finally, this one's a little tougher. A diagram below of trapezoid LMNO, S is the midpoint of LO, and T is the midpoint of MN, so ST is our midsegment. Find the length of ST. Well, what we need to do here is set up our equation properly. And the first thing we're going to do is, once again, just plug in everything we know. We know this is our midsegment, right? Because that's the middle, so that will go over here, 7x minus 4. Our base 1 is 38, and our base 2 is 6x minus 6. To solve this, we just do the same thing as before. We're going to multiply both sides by 2. Multiply both sides by 2. These cancel. We distribute out the 2 on this side. So we get 14x minus 8 is equal to 38 plus 6x minus 6. Now keep in mind, when I multiply both sides by 2, these 2's just cancel each other out. So I'm just left with what was over here. All right, it just comes straight down. From here, I'm just going to solve it algebraically. Put the line down. Let's subtract 6x from both sides. When I do that, this cancels, and I get 8x minus 8 is equal to 38 minus 6. Combine like terms, 8x minus 8 is equal to 32. Add 8 to both sides. All right, let's move it over here, and I get 8x is equal to 40. Divide by 8 on both sides, and I get x is equal to 5. Not done though. We want to find the length of ST, right? So when we want to find the length of something, we plug it in. So ST is equal to 7 times 5 minus 4 So ST is equal to 35 minus 4, which is 31. All right. That is our long video. Sorry about that. Once again, this is the only unit where it's going to be this long. Thank you for hanging in there. You are the Jazz. Keep it real.